Partner Network. Thanks for joining today's Partner Network event. So the main purpose of this session is to provide some valuable insights that will help you enhance your software offerings, increase revenue, and expand your product portfolio. And we are dedicated to adding value to our partners. So today's session is all about showing you how to achieve these goals effectively. So our guest today is Jeff Knepper, who is managing uh, partner and president at Flow Software. Jeff is here to share his expertise and also to demonstrate how Flow software can be a game changer for your business. I believe most of you here are already familiar with Canary. So today you get to see firsthand how Flow software can seamlessly integrate and work together with Canary to optimize your operations. So Jeff's experience at Canary Labs as executive director, who working with data management in time series historians, enable him to speak with authority on shaping scalable data solutions for manufacturers. So before we start the session today, we'll just have a quick guide on the flow. So at the end of this session, we will open the floor for Q&A from our participants. So please feel free to type your questions in the chat box, and we'll address them during the Q&A session at the end after this webinar. So as you may have already seen, this webinar is being recorded. You will after the webinar, you will receive a link to the video as well as slides from our guest, Jeff. So don't worry, we will get the slides and also the PDF and the video.
Yeah, just in case you would like to share it with your other teammates that can't make it today.
Yep. All right. So now that my intro is done, Jeff, the floor is yours.
Thank you.
Thank you, Jeff.
One second, as my PowerPoint decided to crash. Cheryl, it knew that I was doing a backup plan and said, there you go. 1 second, I should be ready.
No problem.
All right, well, thank you for the introduction. And Laura, as you noted, my background was with Canary, and it was after I had started to try to help customers do a better job of managing their information within their organization that I realized that I needed to look beyond the historian in order to help with information management. So my goal today is to speak to you about information management, how to simplify the process of it, and ultimately that will mean eliminating data silos, helping your customers scale their analytics, and securely delivering information to the right people at the right time for proper decision support. So if we're going to talk about information management, I think that means that we also need to first identify that in manufacturing worldwide and in industry worldwide, no one really has a clear strategy for information management. Now, this is a great opportunity for integrators because it means that your customers need someone to guide them into an information management strategy. What have we been doing in the industry for the past 30 years? Well, we have not been doing information management, but instead we've been focusing our efforts on data management. And data management is really all about connecting to a sensor or a device in the field, logging and storing that raw data into some type of a time series database, hopefully Canary, if that's what you're currently using. Often we've seen OSI, now a Viva Pi or a Wonderware historian, or even just a SQL database be used. But data management is really just about connecting and storing data. Information management is focused on how you take that raw data the output of the data management step, and then turn it into something that can be used to drive business. So that means more than just collecting and storing. It means integrating multiple data sources together, processing that data, analyzing that data, adding context, then creating or calculating new insights, and then sharing that information across the organization for decision support. It is a much different process. It is a much different task than data management. So let's talk about how we've been currently set up as an industry when we think about information management. This slide will help position really what most people do, and that is they think of data sources or data producers, and they think of data consumers. Often, where are our data producers and our data producers and our data sources? Well, often they sit at level 2 and level 3 of the Purdue model. Where are our data consumers? All across the organization, level 3, site side, level 4, enterprise side. And when we take on a new data project, that is, we have an idea around some type of insight we would like to get from our data, we follow the same steps each time. We pick an application, we connect down to our data producers, and then we bring that data over to the application to turn it into information. Now, what happens in that area of that application in order to go from raw data to information? What happens is actually information management. So from a step-by-step guide, we first connect to the source, ingest the data, we replicate that data essentially into some database. We then cleanse the data, we normalize the data, we get all of the formats into the same format, we get rid of the outliers or the anomalies or the bad data values. We try to add operational context and shape to the data. Maybe it's identifying process events or calendar periods like shifts or batch runs. With those events identified, then we start to aggregate the data into some type of a KPI. We have to then validate the result, and then we distribute the information. And this is the process that we've run over and over and over again for the last 30 years. The issue is that we keep doing those steps, repeating the process, and doing that work over on the data consumer side, inside of what I call the application layer. So we do this work in our BI tools. We do this work in our analytics apps. We do this when we bring data into Snowflake or Azure or AWS. We do this when we build another report, or we create another internal communication, maybe from an email or a Teams or a WhatsApp message. We keep repeating these steps, and having all of these processing steps distributed across all of these different applications has created an information management nightmare. First, it's expensive. The steps that I've gone through require top talent. Data scientists are often involved, or integrators are involved. It's not cheap for the customer, and they can't do it quickly. There's a lot of code written. Code and scripting creates fragility. As other applications version and increase in age, the code doesn't work the same. Because we've spread the work across many different locations, we don't have the ability to govern the data, and we don't have the ability to govern the engineering behind the data. So the exact same KPI over in the BI tool versus a KPI in a report or a dashboard, they might be describing the same event, but often the values do not match because the underlying calculations or the underlying cleansing or the way that we've handled boundary values or done aggregates like averages versus time-weighted averages or taken an average of percentages, well, we don't have governance even around the engineering. And as a result, we can't scale. The concept of the UNS has come out of this. instead of spreading work across multiple applications, can't we put a unified namespace in the middle? Of course, we know this architecture. It's that hub-spoke model where we connect our producers and our consumers, or our subscribers and our publishers, to one hub or broker. The issue is that the unified namespace won't solve this problem because it's focusing on real-time data, not ingesting, connecting, cleansing, adding operational context, identifying events, aggregating KPIs, validating results, or distributing. The UNS is just a flow of real-time data out to the application, which means those steps still live out at the application in order to combine data from multiple sources, aggregate results, and identify value-added information. So how do we solve this? Well, we take a page from the UNS. We centralize the work. We connect everything to a centralized location where we can process data and turn it into information. And then we publish out to our applications to use that data. By centralizing the work and our data transformation, we pick up that strong data engineering, data and governing engineering governance. We give our subject matter experts from both the OT side and the IT side a centralized place to collaborate. Ideally, if we're going to make this scale, we have to stay away from code, and we want to build this into a templated library format. And not only do we want to create the rules around how we transform the data, but we also want to have engines that are actually going to do the data transformation, pre-processing the data upstream before distributing it downstream. So this is what we call the unified analytic framework. We continue to look at connecting real-time data into the unified namespace. We then also provide the history to the unified analytic framework. The unified analytic framework can then distribute the data to our applications, data that's already been transformed, joined, cleansed, calculated, validated, and can in turn also connect back to the unified namespace, publishing those values in real time as well to the broker. To do this architecture really requires three key components that go into building a unified analytic framework. And this is now where I will shift a little bit into talking about Flow as a product and how Flow will help simplify information management through a unified analytic framework architecture. The first of those three major components is something to handle information modeling. So what is an information model? An information model is going to help an organization define not all data, not every data point, not the entire stack of data that would be in a historian or a UNS. No, an information model will define the key data that the organization is focused on. So the key data being what is driving our business? What are the KPIs? What are the events? What do I need to know for my job in order to measure and monitor and ensure that I hit my goals as an organization? So that key data gets built into an information model. And then using that information model, we can establish governance around how that data is created, how it's managed, and how it's used. Think of it as the model really is what contains the rules for how your data will be transformed and used before being distributed inside of the entire organization. If the information model is the rule set, then we need some intelligent execution engines that will take those rules as defined in the information model and actually execute them. So Flow has three key execution engines that will help us to process the data, enables real-time notifications around the information that's been processed, and then will also automate the distribution or the flow of that data as defined inside of the model. Then finally, the third of those components is the concept of universal information access. So this is where Flow would actually serve as a hub or as a broker in itself, making sure that the information that has been transformed by the engines based on the rules of the model are really easy to get around your organization and has given a single location for the entire enterprise to have full confidence that what they are asking for, they can trust. So for Flow, this is a series of dashboards as well as a REST API. And that REST API is really important because not only can I get information from the REST API, I can search the rules of the model. I can understand all of the metadata that's been associated with any of the calculations that have been executed. And I can even ask for data as it sits in its raw format at all of the data sources that are connected to the information model. So for example, if I have 3 different historians across 3 different sites, I don't have to query each historian individually. If they're connected to Flow's information model, Flow will query the historians for me and pass the raw data I've asked for via the API in one single format. This has worked for many companies around the world. One of our longest standing customers is AB InBev. Rowan Ray, a longtime Flow user and specialist in supply, said, hey, our data management strategy has changed drastically with the need for easily accessible, accurate, and actionable information. And Flow has become the standard tool within AB InBev, with all of their breweries using Flow for real-time information and reporting. Now, what that means for AB InBev is that every day Flow is calculating over 300,000 individual KPIs across 35 different sites inside of their zone. And all 35 of those sites are operating from the same definitions, from the same governed engineering work of those KPIs. They've centralized a template library of how that data should be combined, cleansed, calculated, contextualized, and distributed. And Flow's engine is just constantly 24 hours a day, providing that information into the data streams that they need to run their shift handoffs, their stand-up meetings, their weekly reports, even information that gets directed directly to the C-level. So if we look at the information modeling a little bit closer, what we'll see is that there's multiple benefits from this. First is the fact that your operations are able to unify dozens of different data sources into one single unified view. That means that no matter what the naming standard is inside of a historian or in a SQL table or in a product that you're using, you can unify a functional namespace where everything comes into one place inside of an information model. You can add context, equipment relationships, how you handle time. When does a day start? What does a shift pattern look like for this plant? As well as bring in your subject matter experts that know about the process and get the information that typically stays locked inside of their heads into your data stream. You write rules around how you're going to cleanse data, how you're going to calculate new tags, how you're going to flag events, how you'll aggregate KPIs. You write rules around how you'll distribute the data, when you'll distribute the data, what are the triggers, what is the schedule. Of course, all of this comes with standard user-based security, and anything that happens in the model gets audited, meaning when changes are made, we know exactly what user made the change, when, and even why. For scalability, the model was built on templates, and that means that I can quickly build out a series of rules in my model for a project I'm working on for one part of my operation, and then take that, templatize it, and instantiate it across many parts of my operation. Let's look at an example of this. So what we see here is my Flow config tool, and I'm working over on a model, on a template, and I've got a couple of tags for a power meter, my energy tag, power tag, voltages, and I'm simply creating KPIs by taking the tag, dropping it onto the KPI, and then picking the aggregation that I would like. In this case, a totalizer becomes a 15-minute total using a counter aggregate. Take my power tag, drop it on the minutely bucket, and now I've got a predefined 15-minute power KPI. Here I choose average, and now every 15 minutes, I'll have the average power usage. This time I'll look for a min and a max, again, just by dragging and dropping. No code being written here, which means that I'll be able to scale this quite easily. I'm not even really linking data to this yet because I'm just building a template. I'll link the data where it's sourced after I deploy this out into the field. This is my engineering governance coming in. I'll add another tag here just by dragging the tag over to the metric. This is my power factor. I want to express a power factor in a percentage. And now we'll do an hourly. Again, with an average. And finally, I'll take my power factor and I'll bring it down, and we'll use a calculation feature inside of Flow. With the calculation feature, I can now do a modification on this. So I might want to take a 24-hour moving average, and all I have to do is just change a few little properties here. Tell Flow to take that tag, look at the previous 24-hour range, and instead of just giving me the current value, it returns an array of values, and I'll just tell it to bring back the average. Validate my expression, and my model's really ready for me to go deploy now. If I wanted to do more, I could always come in and decide to do some projections into the future based on what's been happening inside of my model. I could spend more time here, build out events, of course, expand my use case further and further, but that's just a quick taste of what the environment looks like inside of Flow to build a model. Now, the benefits and the value to business is that I'm creating a secure self-serve data access point so that my citizen developers aren't asking someone on the SCADA team to build them a report. They're not asking a data scientist to go into Power BI and build them a dashboard. Instead, I'm asking my people to come get the data that they care about or to build the models that they need as part of their job. And I'm centralizing that work into these governed business rules that everyone else has access to. This gives my subject matter experts the ability to collaborate and encodes their deep process knowledge. And I get to keep reusing this work. So if someone else is working on something that has a power factor from a panel, they don't have to go rebuild that. They can just borrow what I've already built and apply it to their use case. Because it's no code, low code and templatized, it means it's highly scalable, and I shorten my deployment times. Now, the most important thing about all of this is I'm not locking myself into any one vendor platform. I can use any SCADA package I want, any historian I want. I can have part of my solution be inside of Siemens, part of it focused with Aviva or any other open source technology that I might want to choose to bring in, like Influx or Timescale. So this gives me the capability to bring in data together from many different platforms, many different vendors without having to put, as we say, all of our eggs in one basket. The key to scaling this is making sure that you have a flexible architecture. Can it run in Docker? Can it run in Windows? Can I deploy it on the edge? Can I deploy it at site? Can I deploy it at the enterprise? Maintaining platform agnosticism, using template libraries, being API driven, not relying on scripting or code, and giving one spot for my business rules and my data and my engineering to be governed. This is exactly how we've helped industry leaders. Since 2011, Flow was born from a system integration business in South Africa. by process and control experts. It's that deep knowledge of the challenges of manufacturing that have really built Flow and helped both our team and our partners meet the day-to-day challenges that are unique to manufacturing. And we help really companies of all sizes. Of course, we always show the big companies when we do logo slides, but I cannot express to you the number of Flow instances that are helping 100 KPIs at us factories around the world. They're not always huge instances. Let's talk about the intelligent execution engines. Key benefits of the data engine. This is the piece that will process all of the data according to the rules defined in the information model. So our data engine automatically handles late data or modified data values. That means we know that what it was now when you ask us to run the engine isn't what that data point always will be. Often we see data come in late after KPIs have been run, especially with our manual data forms. Operators and team members will go back and change data. They'll say, I previously coded this downtime as a fault due to electrical. Later on, I found out it was actually mechanical. So anytime data changes that's underlying to our data engine, the data engine sees that, reruns the KPIs, versions the results, and then gives you the ability to also trigger all of the other dependent KPIs to also rerun. You'll see that here in just a little bit. The message engine. This is what publishes the information after it's been calculated inside of the apps you're already using. So Slack or Teams, an email, an SMS message, a PDF going into SharePoint. And then the integration engine. Where else do you want this information to be delivered? Does it need to go to a data warehouse? Does it need to go to another SQL database to power a BI tool? Does it need to go back into a Canary as a tag once the calculation has been complete? What's great about the integration engine is that you can define and match the schema of the destination right there inside of the information model, making sure that when the integration engine is processing this information and delivering it, that it delivers and matches the destination every time. This gives you a huge value to business. Data engine is giving your customers absolute trust in the data. I'm going to demonstrate just what that means in just a second. The message engine is going to securely put the right information in front of the right people at the right time in the right application where they're already working. We're not asking people to go look at some other dashboard. You can put this information right at their fingers. And then the integration engine means whatever tools you're using inside your organization, you keep using. If you're using Power BI or you're using Seek or you're using a machine learning application or a data warehouse strategy, keep using it. It's our goal to deliver better information pre-processed with extra context to those applications. Flow is not competing against those applications. We are helping to enable them. At Danone, we saw a 6% reduction in scrap in just 135 days. Their operations team knew that they had scrap overage. They just couldn't quite figure out where it was coming from until all of a sudden they had an easy way to bring data from multiple systems together, define their model, execute the calculations, and begin to fine-tune their process. What started as 2 use cases inside of Danone, after the first use case, success in 135 days, quickly grew to 8 different use cases defined inside of that information model. So let's talk about universal information access. There is a dashboard and reporting component to Flow. If you don't already have great dashboards and reports, or maybe there's some specific features missing from your dashboards and reports, Flow will meet you there by extending that offering. Within the dashboards, you can interrogate every piece of information on the screen. There are dozens of different visualizations available. Within the REST API, you can search the information model, and it provides, as I mentioned earlier, a full registry of all of the data available in its raw format that is linked to the source. Values to business, completely unburdened from a traditional user-based licensing model. So there is no license required for dashboards and reports. It is unlimited and part of our installation. And Flow is really good at capturing manually entered and categorizations of data and building that into the information model. The REST API value to business, a single endpoint for accessing all connected data sources. And it will help you streamline your data lake focused initiatives. So this is an easy way to bring data from one API, connecting multiple sources into a data lake. And finally, we'll accelerate data projects and pilots for other applications because they're connecting to a model that's already done a lot of the pre-work for it. So let's take a look at a Flow dashboard so that we can demonstrate what it looks like to manually capture data, what it looks like to change data, what it looks like to be able to interrogate a dashboard and understand the underlying information. So what you have in front of you right now is a report that I built for this demo about scrap. And so my scrap report currently is for a zone. This is my Midwest zone, and I'm demonstrating a scrap total from two different plants. A plant in my hometown of Bentonville and a plant that is home to the world famous American football team, the Kansas City Chiefs. In Bentonville, I can see that my scrap totals in light blue here at the top are laid on top of my totals from Kansas City. And when I look across my data table, I can see that I have my scrap reduction efficiency, which is a percentage. And this is calculated based on my total scrap versus my target. And for each day in the month of June, I have a calculated KPI based on how I did in meeting my target for scrap. So this is color-coded. It's weighted based on what my efficiency was. And I can see right here that I had a very high number at 130%. So I see this and I question, well, what happened on this day? Let's take a look. On July the 11th, my target was only 500, yet my total scrap was 654. I can click on any KPI or any data point on this sheet, and a bottom screen will pop out. Now for my scrap reduction efficiency, here it is. I can see the equipment information. This was off of filler 1. This was my reject bottle count for the day. And notice I have a tab called comments. Now some comments have already been entered here. Someone by the name of Brooks Robinson said, target needs adjusted. Jeff has been notified. And then I've come in after I've been notified and said, hey, Brooks, I saw this. I will adjust. Zoom in so you can see a little better. Now on my report, based on my user permission as a manager, I can see and click on target adjustment. Target adjustment will take me to a new form. And this form is simply a data table for Bentonville as well as for Kansas City. Because I'm a manager, I can see both. And this is where I am able to enter or change all of the daily targets. So here I am on the 11th where it was 500. And I have the capability to take that, to edit the 500, type over it, and enter what should have been the goal for that day, 1,000. Now, if I click on the 1,000, I get that pop out again, but this time instead of the comments field, I'm over here on the history field. And notice that the history is showing me all of the previous values that were recorded for June the 11th for my daily target. So originally the value was 1,000. and that was entered on the 12th of June. And then that same day, I changed it down to 500. Why is that? Well, if I look at the comments field, the comments would tell me that we were planning on only running half a day. Well, something has changed and we ended up running the full day. So now I've gone back in and entered the value of 1,000. Now, when I do that, automatically Flow's data engine, because it tracks dependencies, knows that that scrap reduction efficiency percentage will need to be recalculated. Let's take a zoom in. Up here's that dependent KPI on the target. And automatically Flow will go in. Oh, there's my comment field. And I adjusted from 500 to 1,000 at the request. So now that's tied as an annotation back to that target KPI. So if I pull the API and access this target KPI, that comes with it. And automatically, right there, my scrap has become recalculated. And when I click on it, same thing. I can see that the scrap used to be 65.5. Then I changed the value to 1,000. It calculated here, and now it's back to 65.5. This is the third version of that KPI. Meanwhile, back over on my report, everything has updated properly. No longer am I in the red. I'm now at 65.5. And I can click on the percentage for scrap reduction efficiency and look what I see. Still the information, where does this get tied to? What's the context? Where's this being calculated from? And then under the details, I can see what is the actual expression. The expression is what was the current value divided by the target times 100. And then each of those variables is showing right here. If I click on one of the variables, maybe I click on the 654, I get a pop out that says that was the full day scrap. And then I have every hour for my production day from 6 a.m. to 6 a.m. Here's the 6 to 7 hour. What did we do in scrap? We did 50 gallons. The next hour, 21 gallons. The next hour, 7. And I can search through this data the whole way down. I can click on any of these single boxes and go look at the raw data as it sits in the historian. But speaking of historian, I can also build links in so that from this dashboard, someone can automatically link over to a Canary trend of the tags that are contributing to scrap. And so with one click on the Canary trend, we pass the date and the tag list to Canary. And now my user is looking at the data as it sits in its raw format inside of Canary's trend axiom. So this is what we mean by universal information access. I don't have to go wonder if the data that I'm being presented is accurate. I can drill down into it. I can make changes if I have the right authority. I can make comments. I can investigate. I can even link out to other applications. These are the types of tools that have helped Clover Dairy reduce their CIP, their cleaning process, by 20%. That means that every single week they have capitalized 8 engineering hours they were spending paying for their flow system in just 6 months. Flow strategy will work for you. To model it, we connect to manual entry sources, time series databases, real-time sources, and SQL databases. Where data is already stored, we create linked memory tags inside of our information model. Where data is not stored, like real-time sources or manual entry sources, Flow creates stored tags inside of our historian. Then the information model defines how we will clean and calculate and combine these tags into one normalized data table. So notice that here we've got tags that are probably living in a historian, like speed or a totalizer. And we've normalized time so that for every single timestamp, we have a value. So where the total continues to climb, speed was the same for 2 periods in a row, but notice that we have nice even timestamps. Kilowatts might be something we're connected to on a web API, so not stored. That means Flow is now storing this data in our historian. And batch ID is something that's living over in a SQL database. So we are looking into the SQL database to see what the value was for this time period, and then we are extending that value, giving it a unique entry in our table for every time there's a different timestamp. This makes sure that when we do calculations, we're not having to worry about trying to match timestamps because everything is organized in a wide table format without any missing timestamps. Now we ask for subject matter collaboration around the information model to tell us what are the events that we need to look for, meaning calendar periods, shift schedules, key process events, alarms, and then when those events happen, how do you want to aggregate these KPIs? How do you want to bring the data in this normalized table together into an aggregated format? From here, we get operations feedback, typically off of Flow dashboards, and then we're ready to write all of that information into the Flow database. That means we're not just writing the KPIs and the events, we're writing the comments and the context that we get from operations. Once it's in the Flow database, we can distribute it out on demand via the API, or as it's coded into the information model, tell us where you want it to go and when, and Flow's integration engine will sync that data over to other applications, to data lakes, to BI tools, back into the UNS, or anyone can come access it from the API. From the API, they can get the KPIs, the events, the data as it's been cleansed and normalized in the table, as well as data here at the original source, all based on the way it's been modeled. So getting started, well, listen, this is not a project, it's a journey. There's no overnight success for information management. It simply means understanding that the way we've done things for 30 years isn't scaling, isn't helping, and doing a shift. We follow a 3-point strategy. We want to first empower operations. We know that if you empower operations, OT team members understand their process. So if we give them a drag and drop tool to build their own analytics and reports, what we'll get from them is context that we can then send with the data downstream to other applications across the enterprise. We want to get that collaboration between OT and IT around how we treat the data, how we build the engineering. And context, context, context. We want as much context as we can get so that everything else that we connect to is more powerful. Typically, organizations start this journey by looking at the next business use case and simply saying, I'm going to build this work centralized rather than going off and trying to write more script in a BI tool or in a data lake. That could mean scrap prevention, product forecast, OEE or downtime tracking, asset performance, batch reporting, one that most historians still struggle with. Maybe it's around some environmental governance with utility consumption or quality assurance or even manual data capture. It's simple. If we continue to do things the way we've done them for 30 years, we won't fix the problem. But if we look to figure out how to scale our information management, we focus on the 3 key components. We will build one centralized place for that work to live, for OT and IT to collaborate, and to apply that data governance. I hope you found this helpful. I'd love to connect with you. If we aren't connected already, please feel free to jot down my email address or find me on LinkedIn. And at this time, I'll pass it back for questions and discussion.
Yeah, we are now opening up for any questions.
Great presentation, Jeff.
Oh, thank you, Kamal.
Just one question about the KPIs. There are some KPIs you've shown, and there are thousands of them, I guess, out there. When you go to a business, they don't know what they don't know. And is there a way to kind of introduce them to the kind of KPIs which are relevant for their context? I know there are hundreds of types of manufacturing, and this is very, kind of a complex requirement. But say if I pick up a specific type of a manufacturer and say, okay, here are your 20 set of KPIs, which are good set, and the top 5 you should be monitoring.
Yeah.
Is there some kind of a guidance you could provide?
Yeah. I'm tempted to tell you ChatGPT is really good actually at guiding that. And I'm not mistaken in saying that. There are lots of resources. I often see them called KPI cookbooks for different processes, for different specific verticals in manufacturing. We have deeply experimented with ChatGPT because we've actually demonstrated that we can build templates by asking ChatGPT to here is the desired JSON output, build a template to this format, and help us in ideation around KPIs for a solar farm. When we compare that to what we've actually seen at solar farms, for instance, 90% of what we get from an LLM is actually valuable. I'm not suggesting that you use ChatGPT, though, to create the KPIs for your customer. Typically, what we have found is that the engineering core within the operations already knows a lot of the KPIs they want, and they're building them inside of Excel files because they don't have a centralized tool to do the math for them or to process the data for them. I know that in my job, there's 5 to 10 KPIs I'm watching every day that is the health indicator of my business. And it's no different than if I was a plant manager or if I was a quality assurance team lead. I would know the 5 or 10 KPIs that I need. And none of those men or women want to have to go into Excel and calculate them. And they've all been burnt by seeing data on a report that they don't think is accurate, or they trusted it and they shouldn't have, or someone questioned them on it and they couldn't defend it. And that's exactly what we want to help them by empowering them to avoid. Once they have those KPIs sitting there and available for them, it's incredible how fast that single group of KPIs then gets secondary aggregations on it. So a total production by batch, by shift, quickly becomes total production of that part or for this customer for the year, or day over day rate of change, or then grows into, well, tell me about what I didn't produce. Tell me about the amount of time that I was supposed to be available that I wasn't. And very quickly, you end up with 30 KPIs that are based off of those 4 or 5 you started with.
All right. Yeah, no. That's a good answer. I guess the operations team, they know what they're measuring and what their pain points are.
Yeah.
But one of the things which I have noticed in IT is when you take IT to the real world, they somehow start to think that they know everything and they can teach us what we don't know. And that's the expectation, I guess, that sometimes you need to fulfill. I know
Yeah.
there are some standards on manufacturing KPIs, but they are kind of locked behind paywalls or so.
Right.
But yeah, the expectation, some of the businesses have that when you bring a tool or when you bring a solution, you teach them also what they don't know.
One of the nice things that I have found is in working with IT, helping them complete the data picture. So what they've tried to build is a snapshot in time of an operations process,
Yeah.
but it's never complete. They might have a sense of what the last 1,000 widgets produced cost, meaning they've taken averages of personnel, they've taken averages of raw goods suppliers, they've taken averages maybe even of electric bills, but they don't know exactly how much raw material came out of tank A and tank B to make the last 1,000 units. They don't know exactly how much that cost to the penny.
Yeah.
They don't know how much utility to the kilowatt hour or gas or steam was used. They don't know how many bottles were broken while those widgets were being made.
Yeah.
They don't know how much unplanned downtime was experienced and what the operator ID badge was that was on that line and what their hourly standby rate cost. We can complete that data picture. And when they realize that, they actually get really excited
Yes.
because they know that they can't do that without operations coding that information for them. And they've never had a tool that operations could use easily to do that would add value to operations. And that's what we're offering them.
Yeah. That's great.
All
One
right.
more point before I leave others. You mentioned at one stage that this is a purpose-built tool for manufacturing.
Yes.
I know IT is a generic capabilities also, which can be applied to other industries also. What was the key reason behind you positioning it as a manufacturing specific purpose-built tool?
Yeah. Yeah. It's because in manufacturing environments, there's more gotchas than there are in finance or healthcare or really retail sales. The data in manufacturing is so difficult because it's locked away in proprietary databases that are often 20-year-old versions out of date. It's tough to get out. When you get it out, data never arrives on time. It can be inserted later on. SQL databases you're reading data from gets modified and new data gets changed. Values inside of our own database will get edited and changed. In our side of the world, daylight savings time every year throws reports off because we end up with a 23-hour day and a 25-hour day. You get systems that crash, like a historian goes offline because of bad comms. And now all of a sudden all of your KPIs would show null or zero. Well, what happens when all that data arrives back? Are the engines built to handle all of these weird one-offs and be resilient enough that they can be trusted in an environment where when a bad decision gets made, it's not a dip in today's trading pattern or in the insurance world. It's people's safety or huge regulatory fines at stake. And so there's a real seriousness, I think, in the world that we all operate within, that most tools that come down to us from above, picking on Microsoft a little bit, AWS a little bit, they don't understand manufacturing still. They're getting better, but they still don't really get it.
Yeah. And so is it safe to say that we could consider this tool for more industrial application, industrial operations rather than retail or finance or those sort of a thing? Is that a better positioning? Yep. Okay. Thank you.
And then for the rest of the group, I will just mention data centers are our new hotspot. Data centers, great budgets, highly scalable, repeated assets that they need to share that information to their customers around the physical state of the assets at high scale. It's big budget. It's a great place if you have those markets to take the solution.
Okay, thank you, Kamal, for the good questions. We do have one question in the chat from Tommy. So he's asking, where does Flow store its normalized data when combining data from different data producers?
Oh, great. Great question, Tommy. So the information model is outlining how we combine data from multiple sources into that normalized table that you saw me visualize. That's all in memory. So we're not duplicating the data. We're leaving the data at the source when it's already been stored. If the data is not stored, we are storing it in our own historian product. That's a flat file, zero data loss, delta compression backend. And anytime you want us to provide that information like our API, we are processing the data in memory and then delivering it via the API. Now, after we have executed the rules inside of the information model, meaning the events we're monitoring, we record those events and their context in Flow's backend, which is a Microsoft SQL database. And we record all of the KPIs that we've calculated also in that SQL database. Of course, again, the API you can use to access, or you write the rules into the model, and then our integration engine distributes and matches the destination schema for real-time data that we've processed, or I'm sorry, the real-time data that we've normalized, as well as we can deliver the results of our calculations.
All right. Thank you, Jeff, for answering the question. So, do any of our other participants have any further questions? You can just type it in the chat. Okay, so I think our participants are either
think,
quite shy or they are very satisfied satisfied with the explanation.
Tommy's asking for some more
another.
information.
Yes.
Data historian. Yeah. So, Tommy, we've been using for the last, and to the group, we've been using for the last 3 years behind the scenes, this flat file data historian. We've recently decided to make it available as its own product. I would, with a data historian background, I can tell you that I'm comfortable recommending it for applications up to 100,000 tags, changing it once per second. It's quite performant that way. And right now we've maximized it to connect across OPC UA as well as MQTT. It comes with the product, so there's no extra charge for it in its current release, and it's quite robust. So this is not meant to replace Canary Historian. If you need a full-blood enterprise historian, Canary's your solution. But when you have a customer that wants to do more with their information or with their data and they don't have anything, you have a choice. You can go down a 6-month road down trying to do a capital raise to go buy a historian, or you can deliver them one solution that's going to historize everything they need, give them the ability to define how they handle that raw data, process it, give them dashboards, and publish it where they want it, all in one package. And that's what we're offering.
There's another question. So Brian is asking for our partners who have other historians other than Canary, how universal is it for them to utilize Flow?
Thanks, Brian. Brian said, Jeff, I can't believe you didn't tell us all of the data sources. So I'll come to the historians last, but Flow connects to every flavor of SQL. So Postgres, Microsoft, Oracle, MySQL. And that gives you access to almost every production system that you're going to find. We'll also ingest CSV files. We have a web API to ingest data. You can use our OPC connectors, our MQTT connectors, our manual entry forms. So that covers all of the data sources except time series. For time series, we connect to every historian in the marketplace. So we've developed a plugin architecture for connectors. If you find some weird old legacy historian that we don't connect to, give us a couple days and we will. We just need access to build that extra connector. But the majority of our implementations aren't connected to Canary. They're connected to Aviva, whether it's Wonderware or OSI or GeoSCADA or Scitex SCADA, Clear SCADA, Ignition Historian, Timescale, Influx. We connect to all of the Microsoft and AWS historians. Yeah, really, I can't. GE, of course, Honeywell, Siemens. I'm sure I'm missing 10, but there's just too many of them.
All right, thank you for that.
Sure.
Do any of our other participants have any other questions? If not, you can, if you have anything to ask, you can either email us at this email on the screen here, or can also drop Jeff a message in which he gave his email in the slides.
Perfect. Well, I'd like to thank our partners at Matrix Invent. You all have been wonderful to work with. I feel like every time I get to see old friends. And thank you so much to the integrators that have been on. We really look forward to helping you bring solutions to your customer that are advancing the ball forward. It's not the same thing that they've been pitched from 10 other vendors. This is really a new manufacturing suite around information management. And we're doing our best to make it as inclusive of all of their needs while staying completely agnostic to enable all of the things they already have without having to rip and replace them to add value. Thank you.
Yeah, thank you, Jeff. Thanks everyone for the participation today.
Thank you.
Have a
Thank
great
you.
Thank you,
Yeah.
everybody. So you will